Welcome guys to today's class on physics practical. In today's video, we want to discuss another important experiment, and that is experiment on bending moment. Yes, this experiment has objective, and this is a diagram. Let's see the objective. To determine the Young modulus of a meter rule using bending moment method. Remember, this meter rule we talk about is equivalent to 100 centimeter rule. That 100 centimeter rule you make use of in your lab laboratory. That is in your physics laboratory. That 100 centimeter rule is what we call meter rule. Okay? Now, what is the essence of performing this experiment? From the experiment objective is to determine the Young modulus of a meter rule using bending moment method. Let's call this a meter rule. You and I know that if I try to bend this, there is the degree of the bending I will apply to this. That is how I will bend this. You will just hear kakarapa, that is, it will break. You get what I'm saying? And there are meter rule that you can bend easily and it will relax easily. Bend again, it will relax again. That means that one that you just bend small, it will just break. We say it is very stiff. Yes, it's very stiff. That one that you bend, it will bend easily and relax easily. We will also say it is very flexible, or it is flexible, so to speak. And so, this experiment is a way of determining quantitatively, in quantity, how stiff or how flexible a given meter rule is. And since Young modulus has a direct relationship with how stiff or how flexible a particular thing is, for example, a meter rule is, that is why we are embarking on this experiment. Yes, that means any meter rule that is very stiff, so that if you just bend it small, you hear kakaraba, it just break. We will say it have high elastic modulus. In other words, the Young modulus of it is very high. Are you getting it? Then those ones that you just bend, it will bend easily and relax easily. Bend easily, relax easily. We will say that they are very flexible, and so they will have lower elastic modulus. The Young modulus of it will be very low, or low, so to speak. Okay? And so look at the diagram and look at the procedure. Let's check it out. Place the beam, that is the meter rule, symmetrically. Symmetrically means if this is my knife edge, if I just keep it, I will make sure that from this knife edge to the end and from this knife edge to this end, that they are equal. That is what we mean by placing them symmetrically. Measure and record the height from the ground. That means without putting this mass, if here is the ground, I have to measure this distance. That is my what? YO. Then place a mass M. Now I will now place a mass 100 gram on the hanger as shown in the diagram above. While placing it, you place it at the what? The middle of it, so that it will now try to what? Bend the meter rule. Are you getting it? It will now try to bend it by pushing it down. Okay? The depression Y of the midpoint thus produced is noted. Now, when you bend it, the distance from the point it bent to the ground, you call it Y. That is what we call the depression. So you note that Y. Then what you now do is that you now say, first, the readings are taken by increasing the loads in steps of 100 gram as Y1, and by decreasing the mass in the what? Same steps as Y2, and their mean Ym is taken. That means when you place mass of 100 gram, it will depress the what meter rule to an extent. You take the measurement, you call it Y1. You remove mass of 100 gram, you remove it. It will what? The meter rule will break out. Will try to push up. You measure the height again from the ground. We call it Y2. Then you get the mean of that distance. That is what they mean by YM. Then when you place 200 gram, you follow that sequence. That when you place it and it depress the meter rule, you take the measurement. And when you remove it, the meter rule will push up small. You also take the measurement from that point to the ground. You get their mean as well. And so that means we'll be dealing with what? 100 gram, 200 gram, 300 gram, 400 gram, 500 gram. Are you getting it? And remember we said this experiment on bending moment, the Young modulus of a meter rule, it has a wide range. It has a wide range of values depending on how stiff or how flexible that meter rule is. Sometimes or most time it has this range 0.33 to what? 3.31 times 10 raised to the power of 9 Newton per meter square. This is about the range of value of your what? Young modulus of a meter rule. It depends on how flexible, how stiff, and also look at what I mean by stiff. How stiff or flexible. Are you getting it? So this range of values you are seeing, it may not also be a Newton per meter square. You have different unit of Young modulus. So it depends on the one you want to make use of. This can also be in dyne per centimeter square. Dyne per centimeter square. How? We noted that 1 Newton meter square is equal to 10 dyne per centimeter square. That is the conversion relationship. Okay? And so what you now do here is that this range means you will be having 3.3 to what? To 33.1 times 10 raised to the power of 9 dyne per centimeter square. That is about conversion relationship. Okay? And so that means for meter rule, you have to be looking at this range of values before you can say that your experimental result is quite alright or okay. Okay? And so that is just it. Now, permit me to make sure that all my units is in SI unit. The reason is because this is Newton per meter square is making use of SI unit. Are you getting it? And so I will convert this to what? To kilogram. We'll call here to be in kilogram. So we say 0.10, 0.20, 0.30, 0.40, and 0.50. Okay? And it goes this. Now, the essence of this experiment we are performing here is for us to see how you can do this experiment without performing it live. Maybe you don't have time and you wanted to maximize your time. You don't have time. No much time is given to you. You want to perform it without touching apparatus. That is the essence of this experiment. Now, you have to note the length of the meter rule. The length means from this to this. That is number one thing you have to note. We noted our L to be 75 centimeter. Are you getting it? So I'll convert it to meter. It will be giving me 0.75 meter. Then this B is called the width or the breadth. This breadth, we noted it to be 2.5 centimeter. That means I'll just use my vernier caliper and measure the distance from here to here. Distance from here to here, that is about the breadth. Then measure the distance from here to here with regards to from this knife edge to this knife edge. So converting it to meter, I will have 0.025 meter. That is because when you divide centimeter by 100, you get it in meter. Then this is about the thickness. Thickness, we got the thickness again using vernier caliper. That means you need to know how to use vernier caliper. We now do the vernier caliper, we check the thickness, how thick. Check the distance from here to here, the thickness. Mount your vernier caliper like this so as to get the word thickness. So when you get the thickness, for in our own we got our thickness to be 0.5 centimeter. That means 0.005 meter. So we have gotten everything in our SI unit. Okay? Then the next thing you have to do is, since you have measured this and these are your mass, only this length is what you have to measure, and the height of this without putting your mass. Check the height. So that means my I need to know what it is. I measured it and it's giving me 86 centimeter. That means once I place this centimeter rule on this knife edge, for instance, once I place it on this knife edge like this, I will measure from here to the ground with my meter rule. Once I measure it, whatever it gives me, I have to note it. Are you getting it? And so, noting that, we now say that YO in meter, let's put it in meter, it will be 0.86. So it is constant. It is what? Constant. You get? It is constant because we will have one YO starting from here to the ground. Then this Y1 is when you put the mass, it will what? Go down. I mean when you put the mass, and when you do what? Y2 is when you do what? Remove the mass. That means your Y2 will be higher than Y1. Are you getting it? Your Y2 will be higher than Y1 because Y2 is when you remove the mass. It will now push up small and take the measurement of that height to the ground. Okay. Now, after noting this, we now say that this Y you are seeing here, this Y you are seeing here, where did they mention it? The depression Y of the midpoint thus produced is noted. How do we get that depression Y? It has a formula. Y is equals to Km, where M is the mass and K represents a constant. Are you getting it? Now, that constant is K is equals to GL cube all over 4EBD cube. Can you see? That is the formula for this K. Now, what do we mean by this? That means since K is constant, we have to use our calculator to what? Compute it based on these parameters we have gotten. What is our G? Acceleration due to gravity is approximately 9.8. We are taking 9.8 meter per second square. Why? Because we are making use of SI units here. Then times the length is 0.75 raised to the power of 3 all over, this 4 is constant, times E. This E means young modulus of that meter rule. So in this range, you have to pick one. So let's pick 0.5. I will be using 0.5. 0.5 times 10 raised to the power of 9. Okay? Then what is our B? Our B is equals to 0. Times 0.025. Then our D cube is equals to 0.005 all raised to the power of 3. So that will be the value of K. Now, what you will do again is you use your calculator to compute this. Use a workable calculator to compute it. You say 9.8 times 0.75 raised to the power of 3 divided by bracket 4 times 0.5 times 10 raised to the power of 9 times 0.025 times 0.005 raised to the power of 3 equals to, you'll be having 0.6615. So approximately your K is equals to 0.6 what? 62. Okay, everything is in 2 decimal place. We say our K is 0.66 what? 2, right? Okay. Now, what we do is we now get the value of each of the Y by multiplying it with this what? M. Your Y1, the first Y will now be equals to this K you got from here. This K you got from here times M. This K you got from here times M. Now, question is, what is the unit of this what? K. What is the unit of this K? Remember that you are trying to get this value of, so the K is meter over what? Kilogram. Meter over what? Kilogram. This K, that is the unit. Because once you multiply with this what? Mass, it will remain meter. Okay? Now, having gotten this, our first Y, 0.1 times 0.6615, that will be giving you 0.06615, which we call 0.662. Okay, 0.66 what? 2. Then this 0.662 times 0.2, 0.662 times 0.2, that will be giving you 0.1324. 0.1324. Stay in meters. Then 0.3 times 0.662. You'll be having it to be 0.1986. 0.1986. 0.4 times 0.662. That will be giving us 0.2648. 0.5 times 0.662. That will be giving us 0.331. And so you'll be noticing that this will be the values of your what? Y. Okay? That is the values of your Y. Now we'll be taking it to what? 2 decimal place. 2 decimal place. We want to make everything to be in 2 decimal place. Here will be 0.005. 0.07. Then the second will be 0.1 3. The third will be 0.2 0. The fourth will be 0.2 that is in 2 decimal place, and the fifth 0.33. Okay, we have gotten our y because it has a formula, and that formula is y equal to km, where k is gl cube all over 4ebd cube. That is about Young modulus. In Young modulus, there are formulas you need to know, and one of those formulas is that y is equal to km and k is this. Now we have been able to get our y equals to this. How do we get our y1, y2, ym? We will tell them that y1 is equals to 2ym minus y2, and y2 is equals to y1 plus what? 1. How did we get this formula? We said that ym mean is equals to y1 plus y2 all over what? 2. So making y subject of formula, this will times this minus y2, we get it. So we didn't manipulate it. This formula is real. Then y2 will be equals to y1 plus 1. Why are we adding plus 1? It's because for us to get our y2, we are to remove the what? The mass. We are to remove the mass. And when we are to remove that mass we have already added, the implication is that the thing will move up, push up small, and the distance will be higher. Are you getting it? That is about our y2. Okay? And so we now say, how do we get our ym? We say our ym from this formula, ym is equals to yo minus y. Since our y is this, and it has this relationship with yo and ym, we know what they called yo and ym. That means our yo is 0.86. 0.86 minus y1, 0.07. That will be giving us our ym. 0.86 minus 0.07. That will be giving you 0.79. Okay? So you do the same, this minus this, 0.86 minus 0.13. That will be giving you 0.73. You do again, 0.86 minus 0.20. That will be giving you 0.66. Again, 0.86 minus 0.26. That will be giving you 0.60. Again, 0.86 minus 0.33. That will be giving you 0.53. You have gotten your ym. Then our y1 is equals to 2ym minus y2. Wow. That means what you have to do here is, what is your y1? Please, here is ym, not y1. Okay. Now, what is your y2? Y2 mean add 0.1. Add 0.1 to what? To ym. That is 0.1. 0. So to get your y2, you say ym plus 0.01. That is what you have to do. If I add 0.01 to this, 0.01, 0.01 plus 0.79. That will be giving me 0.8. I will have 0.80. 0.01, 0.74. 0.01, 0.67. 0.01, 0.61. 0.01, 0.54. So you have seen the formula for y1, you have seen the formula for y2. Now how do we get our what? Y1. You say 2 times ym minus y2. 2 times ym minus y2. Let's check it. 2 times 0.79 minus 0.80. 0.78. Yeah, 0.78. That means our y1 invariably is ym minus 1. Since we say ym plus 1 is y2, I mean ym plus 0.01 is y2. Then ym minus 0.01 will be y1. This minus 0.01, or you use this formula, this minus 0.01 will be giving you 0.7 This minus 0.01 will be 0.65. This minus 0.01 will be 0.59. This minus 0.01 will be what? 0.52. So either you use this formula or you just say add 0.01 to this, you get your y2, because you have to be higher. It has to be higher than y1. Then subtract 0.01 from y1, you get your what? Y. Subtract 0.01 from ym, you get your y1. So you add 0.01 to ym, you get your y2. You subtract 0.01 from ym, you get your y1. That is just it. So you have made your values, your table of values, and that is correct. Okay? Yes. Now you put your unit, and your unit. This one, the unit is very important. You make sure the units are there. Now the question is, plot the graph of y against m and find its slope. Find error in the slope and deduce the Young modulus A. So we see how to do that. Follow us on our YouTube by clicking subscribe if you enjoy the topic, then share, likes, and comments. So keep on in touch with our channel so that you see the part 2 of this video where we talk about the graph. Thank you.